Hi guys, it's Mrs. Millison. All right, we're gonna do the check your understanding on page 480. 480. Okay, a histogram on the left shows the interval in minutes between eruptions of the Old Faithful geyser for all 222 recorded eruptions during a particular month. For this population, the median is 75 minutes, so right about there. Now we use technology to take 500 SRSs of size 10 from the population. The 500 values of the sample median are displayed in the histogram on the right. The mean of these values is about 73.5, okay? So does the simulation provide evidence that the sample median is a biased estimator of the population median? Well, if the sampling distribution of the SRSs, the 500 SRSs of size 10 was an unbiased estimator of the true population median, then the mean of my sampling distribution would equal the true population mean, which means that 73.5 minutes should equal 75 minutes, which it does not. So the answer is yes, the simulation does provide evidence that the sample median is a biased estimator because the mean of the sampling distribution does not equal the true population mean. Okay? I wrote that down if you want to see. Oops. Okay? Because these two are not equal. If it was an unbiased estimator, the 73.5 and the 75 would be equal. Okay? All right, suppose we had taken samples of size 20 instead of size 10. Would the variability of the sampling distribution of the sample median be large or small or about the same? Okay, so this is a sampling distribution based off a sample size of 10. If we had done a sample size of 20, this spread would be a little tighter, okay? It would be a little smaller. Larger sample sizes always produce smaller variability. So the answer would be smaller, okay? So larger sample sizes always produce smaller variability. Okay, describe the shape of the sampling distribution of the sample median. Well, it's left skewed and unimodal, okay? Which makes sense because if this was a good sampling distribution, then the median would equal this median, which would be 75. And if it was a larger sample size, the spread would be smaller. And if it was, again, it was an unbiased estimator with a good sample size, the shape would be more approximately normal. But sample size was kind of small, the medians don't match, so it makes sense that it's a little skewed. Okay, I hope this was helpful. See you next time.